Hello, fourth grade. Welcome back. I hope you have been enjoying Chapter 9 and the math, and I hope you've had a chance to play with some money. Today I am looking at lesson 9.5, and specifically I'll be looking at some of the problems from the black and white pages. I have set up here 9.5 number 2, and so if you've already done that assignment, then this might sound familiar, and if you haven't done it yet, we're working through it right here, right now. Now in 9.5, there is a problem, number 2, and it says, together Xavier, Yolanda, and Zachary have $4.44. If each person has the same amount, how much money does each person have? So here you can see I have Xavier and Yolanda and Zachary. They might resemble Pokemon. They might not. And over here I have a pile of money. Woohoo! And that pile of money happens to in fact be $4.44. And it looks like they're going to divide the money amongst one another. And so some of you, maybe you thought, oh, that's really easy, Mrs. Lewis. Okay, there's $1 for you, and there's $1 for you, and then there's $1 for you, and then, uh-oh, I have this extra $1. And I'm going to have to break it up because I can't actually physically cut this $1 up, right? I won't be able to use $1 anywhere anymore. That would be silly. So I need to make some change. Unfortunately, over here to the left, I have this big pile of money. It's almost like going to the bank. And I'm going to go ahead and break my $1 into some change. Now, hopefully at this point, you are already thinking to yourself, well, Mrs. Lewis, obviously you could break that into dimes or quarters or nickels or pennies. And if I didn't want to have to carry around a bunch of change, I would probably go with the quarter. So we're going to start by breaking that $1 into 4 quarters. And if you went into a bank or grocery store and you said, could I please have some quarters for my $1, you would get 4 of them. So we're going to bring these 4 quarters back over to our problem here. And we're going to add our quarters. Bear with my awesome film quality here. We're going to add these 4 quarters to my pile of change now. And so now it looks like, oh, actually, I have the 4 quarters plus I had the quarters that I already had. And so I'm going to just do the 1 for you, 1 for you, 1 for you. So I'm going to say, okay, 1 for Zachary, and 1 for Yolanda, and 1 for Xavier. Now, so far they all have $1.25, and then I still have a bunch of change over here. And let's see, I could distribute some pennies. I have enough pennies to give each of them a penny. And I could give a penny to each one of these. But as I'm looking at my change, I have a small problem. I have 3 people, and then I don't have 3 of each types of any of these coins anymore. So I'm going to have to make some more change. So here's what I think I'm going to do. I'm going to take that this quarter here, or maybe both of these quarters, because, right, I'm not going to get another quarter. And I'm going to turn these quarters in. I'm going to exchange them for 5 dimes, because 2 quarters, that's 25 plus 25, that's 50 cents. And dimes are 10 cents each, so that's 10, 20, 30, 40, 50. And so now I've got all these dimes over here. I'm going to move them back over to where my problem is. And woohoo! I'm back to 1 for you, 1 for you, and 1 for you. And look, good news, I still have 3 dimes. Now here's where it gets tricky. If I give out these 3 dimes, I'm going to be left with a nickel and a penny. And I'm going to have to figure out how I can break that into change so they can all still get the same amount. But I'm going to go ahead and distribute the dimes anyway, first of all. And then I'm left with a nickel and pennies. And hopefully at this point you're all thinking, well, Mrs. Lewis, you could just take that nickel and you could break it into pennies. And so I'm going to take my nickel over here. I'm putting it in the nickel pile, and I'm going to take an exchange 1, 2, 3, 4, 5 pennies, because 1 nickel is the same as 5 cents. And now all I have left to distribute are pennies. And woohoo! Hopefully you've all looked at this and you realize that I can absolutely do that, because I have 1 for you, 1 for you, 1 for you. I had 6 and I'm dividing it by 3. That means they all get 2 pennies. And now if I count how much they each got, they all have $1. They all have $1. And then I see a quarter, a dime, 2 dimes, and 3 pennies. And so I would say $1 and 25, 35, 45, 46, 47, 48. $1.48. Now, the really important thing is to know how to write this. And in this case, I'm going to put the money sign. I'm going to put that cool little money sign. It's like an S with 2 slashes through it. And then I'm going to put a 1 and the ever so popular decimal point, $1.48. And that is your answer for 9.5, number 2. Xavier and Yolanda and Zachary all have $1.48. Hello, 4th graders, welcome back. I am still on the black and white page for 9.5, and now I am looking at number 5. And I'm going to go ahead and read you the question first. And it begins with, Becca has $12 more than Cece. Dave has $3 less than Cece. And Cece has $10. How much money do they have all together? Now, you can see here that I have Becca right here, Cece right here in the middle, and Dave over here on the right-hand side. And I've made some notes. I have put the information from the problem right above each character. And Becca has $12 more. That's the plus 12. And Cece has 10. We know that for a fact. And Dave has $3 less than Cece. And I'm going to go ahead and solve this problem by first starting with what do I know, which is that Cece has $10. And that might not be the prettiest 0, but I'll fix that. So Cece has $10 and Dave has $3 less. And so if I'm thinking 10 minus 3, I know Dave has $7 because 10 minus 3 is 7 and Dave now has $7. And Becca over here, Becca's been saving. Becca has $12 more than Cece, and so that's $10 plus $12. And Becca has $22. And to solve this problem, the first thing I had to do was figure out how much money each of these characters had. And then the real question that they want an answer to is how much money do they have all together? And so this actually, it turns out, is really just a pretty straightforward addition problem. I have Cece's $10 now plus Becca's $22 and finally Dave's $7. And I want you to pay attention to one thing. Take a look at how I lined up my addition problem. I'm careful to remember that even though I have 2 new place values, I still need to respect the rules of stacking my place values. And I'm going to pretend that maybe those are a little bit neater. I have nothing here in the tenths and hundredths, so I can just bring those down. I'm going to bring down my decimal point, and I'm adding. So now it's 7 plus 2, which is 9, and 2 plus 1, which is 3. And I don't want to forget my money sign because I'm talking about money. And the answer is $39. Becca, Cece, and Dave together have $39. Welcome back. Here we go again. I am on chapter 9.6 and I hope you're enjoying this unit. I think chapter 9 is a ton of fun. And right now I'm looking at adding fractional parts of 10 and 100. And that's the title of the 9.6 lesson. And some of you might have read that language and thought, oh my gosh, Mrs. Lewis, I don't know what that means, fractional parts of 10 and 100. And so I want you guys to remember that the word fractional, right, means pieces of. Frac means to break. So fractional, these are just pieces of 10 and 100. And so right here, I have a problem in front of me, and it's from the black and white page of 9.6, and specifically, this is number 3. And so if you've done that, great. And if not, here it is. You'll be able to use this video to solve it. And on number 3, it gives us this problem. It says, I have 9 100ths, and I'm adding 9 tenths. And I'm showing you the money at the bottom so we can think of why we would actually want to know how to solve this problem. And so 9/100ths is exactly the same as saying I have 9 cents. And if I wrote that as a decimal, I would have the decimal point. I would have a 0 to hold the space of the tenths because I have no tenths here. But I do have 9/100ths. And so hopefully from the practice of lessons 9.1 through 9.4, you remember that 9/100ths is written just like this as a decimal point, holding the space for the tenths, and the 9. And over here I have 9 tenths, and this guy written as a decimal looks just like this. Now, because I just created or just wrote these as decimals, some of you might already know the answer. You might be looking at this thinking, well, I can add it if they're in decimals, but what happens when they're in fractions? Well, you have a few different things you can do, but the easiest is to think, I need a common denominator. And if you remember the rule that says that all place values are 10 times the next place value, in this case, my hundredths is going to be 10 times my tenths. And so all I need to do is multiply by both my bottom and my top by 10. I'm going to change this 9 tenths, and it's going to become 90/100ths, because 9 tenths is the same as what I have here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths, right? 9 out of the 10 pieces I need to make one whole. And it's the same as 10, 20, 30, 40, 50, 60, 70, 80, 90 cents. And that could be written this way, it could be written this way, but either way, it doesn't change the fact that it is actually 90 cents. So now that I've converted this to 90/100ths, I have a whole new problem. I have 9/100ths plus 90/100ths, because I could go to the bank with these 9 dimes and exchange those 9 dimes for 90 pennies. But that would be a lot of change in my pocket, and I probably wouldn't want to do that. Instead, I'm going to say, well, now I have the same denominator. So when I add these, my denominator does not change. Same rules apply. And I'm going to keep the 100ths at the bottom. I'm going to say that 9 plus 90 is 99. I have 99/100ths. Hopefully you're thinking, Mrs. Lewis, that's 99 cents. You almost have $1. And if you were down here at decimals and you already added that, then you know that this 9 tenths plus this 9/100ths is 99.